I'm going to talk a little bit about today how you can use the cloud for your dev test environment, some of the things that you can take advantage of as MSDN customers that let you use the cloud for free, and hopefully kind of excite you and motivate you to give it a try if you haven't already. Quick poll of hands, how many people are actually using Windows Azure today? Good. Good news is there's not many hands. That means that for the next hour, I can hopefully surprise and delight you with what we have. How many people here are MSDN customers? Great. How many people here know that by not using Windows Azure today, they're giving up thousands of dollars of free cloud credits? OK, cool. And hopefully the rest of you will know that in the next hour. So at a high level, in terms of kind of what is Windows Azure, I think a lot of people probably heard the term and certainly heard cloud mentioned a lot. At a high level, in terms of Windows Azure is Microsoft's cloud computing platform. And we've kind of focused a lot over the last year or two on kind of three core dimensions of it that hopefully you'll see kind of reflected throughout my talk here this morning. One is looking to make it very flexible. We want to make sure that from a cloud perspective, you can use it for a variety of different things. When Windows Azure first came out about 2 or 3 years ago, it was very much focused on something we call platform as a service, which was a way that you could kind of re-architect and do what I call greenfield applications, so brand new applications, and take advantage and build a cloud scale-based application. And that was very powerful. We have lots and lots of customers taking advantage of it. But one of the things that we heard from a lot of customers is, hey, the number of times I create new projects, that doesn't happen every day. It's much more often I'm extending existing projects. And one of the things that we've kind of focused on over the last 2 years is continuing to make progress on our platform as a service capabilities. But at the same time, making sure that you can also integrate any standard virtual machine that you might already have, use any existing software or any existing capability that you want to integrate with, and make sure that it works inside that cloud environment as well. So if you've got a Windows Server machine or something that runs inside Windows Server, you've got something that runs in Linux, you've got an existing network, including access-based applications that you want to integrate, we now have with Windows Azure the capability that you can do that. And we think really kind of the ability to have both platform as a service capabilities, where we provide more of the management of those services and provide net new capabilities, coupled with the ability to run infrastructure as a service, basically virtual machines running any code you want, ends up being the best of both worlds. And I'll talk a little bit more about that this morning. We've also spent a lot of time with Azure over the last 2 years, making sure it's really open. And by open, that means many different things. But at a high level, in terms of, from an openness perspective, making sure that you can use whatever tools, whatever operating systems, whatever databases, whatever existing assets that you already have. How can we make sure you can use them inside our cloud? So we support Windows Server. We also support Linux. We support a variety of different databases. Obviously SQL Server, but we also support MySQL. We have MongoDB. We have various other NoSQL stores that are available. And we actually just recently announced a partnership with Oracle, which allows you to even run Oracle databases inside our cloud if you have those systems as well. Beyond just sort of supporting different operating systems, languages, and databases, we're also, from an openness perspective, trying to make sure that all of the protocols and all the work that we do, if there's an existing protocol out there that's a standard, how do we embrace those? And so you'll see that also reflected throughout the talk and throughout our stack, where we use open messaging protocols like AMQP. We use open distributed caching protocols like Memcached. And so you can basically integrate, and we use open authentication protocols like OAuth. And so you can basically use a variety of different open protocols and interoperate in a rich way. And then lastly, we try to make sure it's super solid. And at the end of the day, we know that a cloud is a big responsibility in the sense that we're hosting applications and providing a lot of things that, from a company perspective, if we go down, you go down. And so we also try to make sure we've architected it in a very solid way and that we run it with an enterprise-grade SLA. So those are some of the attributes. And we think, hopefully, the combination ends up being really powerful. And this ability to kind of run both platforms as a service capabilities and virtual machines, the ability to use both the best of Windows and the Windows ecosystem, and Linux and the best of the Linux ecosystem all together, ends up being something we think is pretty special. In terms of kind of where we're deployed around the world, Windows Azure is deployed in multiple what we call regions around the world. which basically means as you build and deploy your applications, you can choose directly inside Visual Studio or within our admin tool where you want to run those applications. So we don't just have kind of one cloud somewhere. We have many, many different data centers, many what we call regions around the world that you can choose from. So within North America, we have 4 active regions today. So we have one on the East Coast, one on the West Coast, one in the Midwest, and one in the South. And so you can choose whichever region is closest to your particular customers. We have multiple in Europe. We have multiple in Asia. And we recently announced that we're opening new regions inside Japan, within Australia, and we've recently opened 2 more within mainland China. We're actually the first cloud provider there. And so again, the cool thing is you as a developer can choose where you want to run them. You'll notice that I mentioned 2 in a lot of places, 2 in Australia, 2 in Japan, 2 in China, 2 in Europe, 4 in the US. One of the things we try to do also as we target different geographic regions is to make sure we have multiple regions available within a particular geographic unit. So within the United States, we have 4 different regions. And we make sure that all regions are at least 500 miles apart so that you can also have confidence that in the event of a natural disaster, a meteor coming and wiping out that part of the world, you know, your data and your apps can live somewhere else. That's a little, how's that for an 8 a.m. you know, or, visual? But you know, it does mean that you basically have that flexibility and confidence to know that you can actually depend on this from a business perspective. And you know, hurricanes, natural disasters do happen. You know, this gives you a lot of flexibility as you build your applications to basically run it anywhere. How many people have ever seen the inside of a data center? Cool. How many people have ever seen kind of a standard closet that people have stuffed white box servers in? Yeah, okay. Ours is a little different, but thought I'd just show kind of a brief view of what the inside of one of our data centers looks like. This is our Midwest data center. Basically, we have these huge containers filled with thousands of servers. We don't have many people in the data center. The ones we do have, though, are very strong. Basically, we assemble these containers outside with thousands of servers. We wheel them in, we plug in cooling and power, and from that point on, it's a complete lights out kind of operation. And so anytime you go and deploy a virtual machine or deploy an application, there's not someone running around pushing buttons. We're actually sending a REST command to Azure, and then Azure basically picks one of those containers, picks the servers within it, and deploys your code and your infrastructure in an isolated, secure way within them. And it's completely automated. And so the cool thing from a developer perspective is that automation means you can do a lot of stuff. You don't actually have to wait around for someone to deploy something for you. You don't have to wait for someone to order hardware. You don't actually have to wait for anything. You can basically, within Visual Studio, within our admin tool, fire off your commands. Again, whether it's a GUI gesture, whether it's a PowerShell script, or whether it's C# code that you write using our service library. And you can basically deploy these machines and do everything you want in a fully automated way. And that power and that flexibility where, as developers now, you never have to wait on someone to bring up your infrastructure, I think is probably one of the biggest mindset shifts that you'll find as a developer approaching the cloud. And it ends up being really powerful, really liberating, and really empowering, because it suddenly means you can do a heck of a lot more than you did today in a fraction of time. What's also nice about the cloud, and in particular Windows Azure, is you pay only for what you use. And so I'm going to show lots of demos today of different scenarios. I'll talk a little bit in a bit. If you're an MSDN customer, you can do everything I'm doing today for free forever. Basically, as part of your MSDN subscription, we give you up to $150 of free Azure credits that you can use on any resource. And so literally all the demos I'm going to show you today, you could do at no cost. You don't even need to give us a credit card. As a developer, you can walk up to our website and just do. But once your company goes and wants to deploy production applications, you do pay us, but you only pay for what you use. So there's no upfront license costs. You don't have to buy Windows or SQL. You can just basically rent them by the hour or by the minute inside our data center. And if you decide you don't need that application or that application isn't panning out the way you want to, you can just turn it off and the billing stops. Likewise, if you need more VMs than you thought, you can spin up more elastically as you need them. And you're only paying for the minutes that you use. So if you need them, a lot of machines during the day, but it turns out you don't need any of the machines at night, you can turn them off overnight and not actually get billed at all. and then power them on automatically at 5 a.m. in the morning, or increase your capacity in the morning as you need the load, and you're only paying again for what you actually need at any point in time. And that also is a change in mindset. And the nice thing about that mindset change is it doesn't just save you money, which is a really nice thing, but it also changes the way you think about projects, I think, even within traditional organizations, where instead of having to decide what's the return on investment if we bought all these licenses or all these machines, instead of having to say, gosh, we need to reserve this much space in our data center, we need to buy all these servers, we need to buy all these licenses. If you calculate how much money that project might cost, up front there's a heck of a lot of investment that you need to make, be confident you're going to get your return on in order to stand it up. The nice thing about the cloud is you don't have to worry about that upfront cost, which means that you can literally sort of, as long as you think you can get the return on investment, you can spin up and spike a project, try it out, and then scale as you need. And again, I think that ends up being really powerful for developers. So with that, I'm going to go ahead and jump in and show a couple demos of this in action to hopefully make it a little bit more concrete and walk through kind of the experience and kind of how you use this both within our admin tool, within Visual Studio, and hopefully show off a couple scenarios that pretty much everyone in this room could say, wow, okay, I could actually take advantage of that. And the first set of capabilities I thought I'd walk through is kind of one of the more basic ones, but really also one of the kind of fundamental ones that I think pretty much every user can actually benefit from, which is our ability now to host and run virtual machines inside Azure. And basically, we allow you to stand up your own Windows servers, your own Linux virtual machines, or if you have your own operating system, you can upload and run that too. And so you can basically run whatever operating system you want. You can run whatever you want within that operating system. You're a full administrator on that machine. So if you want to run SQL, you can run SQL. If you want to run MySQL, you can run MySQL. If you want to run MongoDB or any other NoSQL database, you can do that too. We also, as part of this, which we'll demo a little bit later, have what's called virtual private networking support. So you can run these machines up in the cloud, kind of isolated in their own sort of environment. Or if you want to, you can bridge or join those machines to your existing corporate environment, or just tunnel into those machines from your own dev machine and set up a virtual private network where it looks like literally those servers are just down the hall in your server closet or inside your local data center. And again, that flexibility means you can do pretty much anything with them. So enough talking, let's do some demos. So this is kind of our website here. You can go and sign up. We'll talk about that later. But basically, once you sign up, you click our portal link, and it will drop you into kind of our admin portal, which runs in the browser, and basically gives you full access to everything that you want to do within Windows Azure. And so basically, there's a bunch of services. I'll talk more about some of them kind of as the talk progresses that you can manage directly inside our admin tool. And then you can also go ahead and create new services from scratch, and we have lots of different types of services you can create, one of which is a virtual machine. So let's just get started and do a quick create. What would you like to call our first virtual machine together in the cloud? Access. Rocks. There we go. Turns out no one has taken that name. That's what that little green check means. We could run with a variety of different server images. So we have Windows Server 2012. We even have the new Windows Server 2012 R2. So if you want to try out the new server release that's coming out later this year, we got SharePoint, we got SQL, we got BizTalk. If you want to try out Visual Studio Ultimate 2013, the release that's about to come out, guess what? We have an image for that too. And so you could actually, if you don't want to install it on your own dev machine, you can go ahead and create this image in the cloud, and then you can RDP into it, and you can do full Visual Studio development inside Azure as well as part of that. So it's a great way to check out new features, and it's the ultimate version, so you can use all the features. We also have Linux, so you can actually run a variety of different Linux distributions. We got SUSE, we got CentOS, we've got Ubuntu, so you can use a variety. And these are just our kind of curated images that we maintain, and we patch them and keep them up to date. We also then have a community gallery that has literally hundreds of different images with other kind of things pre-configured and pre-installed in them. But since this is an access demo, we're going to go ahead and just pick Windows Server 2012. I can select an admin username, password. And then I can basically pick where in the world I want to deploy this. So any particular preferences, Europe, Asia, or North America? Europe for sure, OK. North Europe, did that work? OK. Hit create, and basically, that was it. And so what we've just done here is selected to create a new Access Rocks virtual machine in Northern Europe with Windows Server 2012. Basically, what the admin tool just did behind the scenes is fired off a REST command to Azure. And our service management then reached out to that data center, selected a container, a server, and it's basically in the process of copying a vanilla Windows Server 2012 image and booting it up. And that'll take between 3 and 5 minutes on average. And at which point it'll be running, and we can remote desktop in, and we're full administrators on that machine. We can install Access and everything else to our heart's content. Life will be great. This is a machine I created last night. And so you can see so it's already been deployed. Basically, once you click on it, you'll notice our dashboard view gives you a bunch of kind of monitoring data about the health of the virtual machine. So I can see CPU, disk I/O, how much cores I'm using, et cetera. What I can then do if I want to tunnel into it, there's a little connect button at the bottom. Go ahead and hit open. And I have to remember what the username and password was. This is the hardest part of the demo. Cool. And it looks like I remembered it. There we go. And so directly inside the browser here, you can see I can go ahead and remote desktop. And now I'm logged in to this machine that's running in a remote data center with that image fully loaded. And that's basically how simple it is in order to create a virtual machine, remote desktop into it. Again, I'm a full admin. I can install anything I want on this, including Access. If I reboot the machine, it'll be there. And I can basically now run pretty much any existing workload that runs on top of Windows Server inside this environment. So that's a little bit in terms of kind of how easy it is in order to actually create and set up this type of system. In terms of, I'll go into a little bit more detail and show off some cooler features in just a second. A couple things kind of to highlight here is by default, I just have a standard OS partition that's been created for me. It's about 127 gigs by default. One thing that's cool, though, is you only pay for what you use. And so I have a 127 gig disk. But if I don't put anything in that disk, I actually don't pay for the disk. So if I put in a gigabyte in the disk, I only pay for a gigabyte of storage. I don't actually pay for what the volume has been formatted for. It's only actually as I fill up that disk that I actually pay. And the rates for what you pay, depending on how much storage you have, are in the pennies per month per gigabyte. So it ends up being kind of cost effective from a storage perspective. I could then, if I wanted to, attach data drives as well. So if I wanted to attach an empty data disk to this machine, I could go ahead and do it. We support the ability to create up to 1 terabyte drives, and you can have up to 16 drives per server, depending on the VM size. So you can basically choose from a variety of different sizes. We also have a variety of different virtual machine sizes in terms of cores and memory. So pretty easy for you to go ahead and attach storage and start doing things with it. A couple of things that we do that are nice from a storage perspective that are a little different from most cloud environments, and it's also different than most traditional server environments, is this virtual machine that we're running does have a local disk attached to it. But when I format drives and when I attach drives to that virtual machine, we're not actually just writing it persistently to the local drive. We actually back it up with something we call the Windows Azure storage system. And basically, the Windows Azure storage system is a set of clusters that we run. You can think of them like giant RAID kind of like clusters, but they're a little bit more fancy than that. And when I basically create a drive and I attach it, whether it's the boot drive or whether it's actually a data drive, we persist your data across the storage system, and we do it in multiple physical drives. And so we make sure that your data is always logically in at least 3 locations on 3 different servers within the storage stamp. The benefit there is if you ever have a issue where that server or that disk fails, we can automatically replicate a 3rd copy for you, and your virtual machine never knows there's a problem. And so we basically make sure at the storage layer that we abstract that out for you. And so from a virtual machine perspective, it just looks like things keep humming along. So it gets you much more reliability and helps make sure that your disk storage is always available. The other thing you get as part of this, by default, you can turn it off if you want to, is a feature that we call continuous storage geo-replication. It rolls off the tongue. But basically what that means is you can have a storage account, and by default, if you create it with this geo-replication turned on, it will make sure that everything you write to those drives is copied in the background to another one of our regions in the same country, so we don't leave the geopolitical boundary, so it never leaves the US, or if you're in Europe, it never leaves Europe. That's at least 500 miles away. So that means in a case, again, of a natural disaster or something really bad happening, like a meteor wiping out that particular part of the country, you know that your data is at least 500 miles away, and even if you don't survive, it will. Access will never die. Remember that. So it's a nice feature in terms of from a business continuity perspective that you can depend on. And again, you can turn it off if you want to, but it provides a nice way that in the background you can go ahead and save your data. Another couple things that are kind of cool about how the system works, I think are particularly interesting from a dev test perspective, is because we're storing all of our drives in a storage system, I can access it not only through this portal view, which is very much a virtual machine view, but we also now give you the ability where you can drop down and browse those disks themselves and use those physical disks effectively as kind of volumes that you can manage independently. So what I'm showing here is a third-party tool called Cloud Explorer. You can also use Visual Studio to manage this, but this one's a little bit easier to see. Basically, what I've done here is I've connected to my storage account within Windows Azure using this. And what you can see here is a couple of files here inside my VHDS container within my storage system. And these are basically my virtual machines saved as .vhd files within there. And that's the same VHD format that you use with Windows on premise, whether it's with Windows Server or if you got Windows 8, it includes the VHD-based hypervisor built in. And what that means is that virtual machine we just created, or let's say we put access in, I could go ahead and see it inside here, both the boot drive as well as the data disks. And if I wanted to, I could go ahead and, this is the one we're logged in, go ahead and hit download. And that would basically download that data drive to my local desktop machine, and I could boot it up locally. And so it's the same physical VHD file format that we use on premise, we use in the cloud. And so you basically have that, as part of that, the ability where you can very easily move your VMs around in the cloud, between our data centers in the cloud, or on premises, either on your dev machine, your test environment, or in a production server that you want to run locally. And that ability to kind of use the same VM anywhere, there's no import-export required. You can literally download and upload just by dragging files in and out of this view. Ends up being really powerful and gives you lots of options. Again, both for production scenarios where you want to be able to move your production workloads around, but it's also really useful from a dev test perspective because it means that you can develop in the cloud, and then when you're done, download it locally and actually run it on your existing production hardware, or vice versa. A couple other things that we do with Windows Azure that are kind of nice, and from a cloud perspective, you kind of need to think a little bit about, and we try to make it really easy. It's basically to be able to handle scenarios where you want to scale out your system across multiple virtual machines, as well as where you want to build in reliability and redundancy, so that in the event of an issue with a particular virtual machine, your customers don't know and continue to operate just fine. So one of the things that we do that's kind of nice is we have built-in load balancing and high availability support included as part of each virtual machine that you deploy within Windows Azure. So it's not an extra charge. You don't need to pay for a load balancer, which is different than most cloud vendors. It's actually built into the virtual machine cost. Basically what this means is you can define something we call an availability set. Give it a name like web tier or database tier. And then you can place any number of virtual machines inside that availability set. And what we then do is guarantee that within Windows Azure, we'll place those virtual machines on separate physical servers within our data center and make sure that those physical servers are powered by different power units and have a different top-of-rack router switch for the network. And what that means then is anytime you have a physical hardware failure inside our data center, that happens occasionally, a server blows up or has an issue, We can basically ensure that only one of your VM instances is impacted, that your whole application can't go down. And we automatically will then spin up a new copy of that virtual machine on a separate server for you. And once it's available, bring it back online. And so it provides a nice way that you can effectively build in redundancy, again, all through software in a very clean way as a developer. The other thing that we then provide inside Azure is a load balancer. And so what you can do is basically set it up so that you can have a load balancer with a public IP address that's available to the outside world to hit. And then we'll automatically round robin and send traffic to different individual VMs that you've configured. And the benefit there now is, again, if you have one of these machines have a physical problem or your software starts having problems, or your web server crashes, we'll basically automatically take that machine out of rotation from the network load balancer and start sending traffic to the other machines. And if it's a physical problem, like a server dies, we'll spin up a new copy of that server automatically. If it's a software problem and you got a bug in your code, you got to deal with it. But if it's a bug in our code or it's a bug with the server infrastructure, we'll automatically spin up a new copy and once it's available, add it back into the network load balancer rotation. And again, the cool thing about all this is we do it for you. You don't actually have to ask someone to go ahead and plug things in or manage it. And as a developer, when you're actually creating your virtual machines, you have that flexibility to set up all these rules, literally just by configuring those virtual machines as part of the creation process, or by adding them a little bit later on after the fact. So what I thought I'd do is just show a quick example of this in action. So we go back here. You can see our Access database system actually is deployed and running inside North Europe right now. Now I only have a single VM running inside Europe. Actually, we can just load it up. So this is now booted. If I wanted to, I could remote desktop in and literally install Access and be good to go. You'll notice we do have an endpoints tab on each virtual machine that's available. By default, when we create virtual machines using the portal, we make it available so you can remote desktop into it. And then we also enable remote PowerShell, and we pick random ports for security reasons. Basically, think of the endpoints tab here for a single virtual machine like we have right here as basically a firewall around the virtual machine. And you can choose which ports or which protocols you want to allow in a secure way. So I could say add, and I could basically pick from a variety of protocols. So I could say I want SMTP, and we'll automatically configure the ports for you. And then once you hit OK, we'll basically open up the firewall, and then you can do SMP traffic to that individual virtual machine. And you'll notice down here there's this little create a load balance set option. And if you select that, if you have an extra virtual machine, or once you select that, if you have multiple virtual machines in that location, you can set it up so that you have what's called a load balance set. And we'll automatically direct traffic to multiple of those virtual machines within a load balance set. And it's literally all you need to do is just add it, hit OK, and away you go. The probe settings here are actually new. We just shipped them in Azure, I think, about 2 weeks ago. Basically, our load balancer will automatically probe that server every 15 seconds. By default, you can change it to be every second if you wanted to. And effectively, if 2 attempts fail, we'll treat the machine as having a problem, and we'll pull it out of network rotation automatically. And so literally, as a developer or as administrators, you're setting this up, just configure these settings, and you now have load balancing set up for your virtual machines, literally in a matter of seconds. Last night, I created 2 virtual machines because I wanted to show the load balancing in action, VM0 and VM1. And so you click here, you can see I've opened up HTTP as well from our web server. If I click Edit, hit Reconfigure here, you can see I've set it up so that I now have both virtual machines load balanced in a single set. So you can kind of see I have 2 machines that are joined within it. And if you click on this Configure tab, you can see I have a availability set called Web Availability Set that I've added both of these virtual machines within. What that basically just means is it tells Azure, please make sure these virtual machines are on separate servers, separate power supplies, separate top-of-rack switches. Make sure the load balancer is sending traffic to each of them independently over HTTP. And if a problem occurs on one of those servers, we'll spin up a new copy of it. If a machine becomes unavailable, we'll automatically pull it out of network rotation. So that's literally all you need to do in order now to have a completely load-balanced infrastructure. And then if I hit it, I can hit it with the DNS, or I can hit it with public IP address. You can see it says virtual machine 2, and then depending on our load balancer, well, if I kid this enough, it'll come back to virtual machine 1, trust me. But it's basically now just directing traffic between those two machines. So really easy way you can set up for high availability and with load balancing in mind. Last sort of demo I'm going to show now with virtual machines here is something called virtual networks. So you saw it's really easy to create virtual machines. We can set up for high availability. We can copy in and out data. We can do storage. Last kind of trick we want to show and highlight here is the ability to have a virtual network. And what this means now is you can have machines running inside Azure that you join to your corporate network environment or any other network environment that you want. And we basically provide the ability for you to create virtual networks. You can provide any IP address settings that you want as part of them. So you can define your own subnet rules that match your on-premises network. And it provides a way that you can enable really rich hybrid environments where you might have your databases still living in your corporate environment, but applications that process them or reporting apps running in the public cloud environment. And you could either tunnel and access that thing directly, or one of the cool features of SQL Server that we just enabled inside Azure also about 2 weeks ago, something called Always On, where if you wanted to, for example, you could replicate your data from your on-premises environment over a virtual network to SQL servers running inside Azure, so that if Meteor ever hit your own local data center and wiped out your data center, you could have a copy of your application running in the cloud with the data automatically, transactionally up to date, running that you could actually fail over to, or whoever survived could fail over to. The other thing you can do here in these types of environments with that always-on support is you could actually run your transactional workloads locally on premises using your existing servers. But if you had BI reporting tools or offline analysis, you could take advantage and run your BI reporting apps against the version in the cloud and use the cloud to scale out that way. And so it enables a bunch of interesting scenarios where you can leverage the fact that you can run Windows in both places, SQL in both places, .NET and Visual Studio in both places to create interesting environments. So we have two types of ways that you can do virtual networks. You can do what's called a site-to-site VPN tunnel, which is kind of the way I've been describing it for some of these scenarios, where I might have a test environment or a production environment running in the cloud. I can have the same subnet as my corporate headquarters environment, and I can then have a secure network tunnel across the internet that connects the two. Everything's encrypted, so you don't have to worry about someone sniffing the wire. It's a completely SSL secure-based connection. And the way our VPN technology works is we've designed it so it works with any existing VPN, or pretty much every existing popular VPN hardware environment. So if you've got an existing Cisco router or Juniper router that you're using for virtual private networks already on premises, you can go into our portal, you download a script, you run that script on your Cisco router, and at that point then the virtual machines you're creating in the cloud can be part of your corporate environment and corporate network, and your existing IT staff can manage it. We also support software-based VPN devices as well if you use those. So it makes it really easy to connect your network. This is what we call a site-to-site model, where you have an existing network of many machines on either side that you want to securely join across the two. We also have a really cool feature that no other cloud vendor currently has, that we call point-to-site, which basically allows you to set up individual machines, whether they're servers or more typically dev machines, that can then VPN into the cloud in a secure way, and also join the virtual network that you've defined inside Azure. And this is really useful for a couple of scenarios, one of which, again, is for developers. So if you want to set up a dev test environment, or if you want to set up multiple machines that your developers can actually access and use, but you don't want to go over the public internet. You don't want to make sure that someone could sniff something on the wire. And in fact, you might not even want the machines in your test environment to have a public IP address, so that no one could even, forget firewall rules. I don't even want to have an IP address. I don't want anyone to be able to access it remotely. You can set up a virtual private network, turn off all outside ports on that network, and then require that the only people that can access it are ones that actually tunnel in using this VPN technology that have a secure cert and a secure password, and then basically remotely manage it. And that's a cool feature that we support, which I'll demo in just a second. Key thing about this is it means that you can literally from any Windows PC join a network inside Azure and have secure access to it. It does not require your IT department to do anything. That you don't even have to tell them that you're doing it. I don't tell mine. But what's cool about it is because it basically doesn't require any hardware devices. Literally, any copy of Windows, you just download the VPN cert and a little tool that we provide through the portal, run it, and then you can literally just join it using the standard Windows VPN technology. It'll tunnel through the existing SSL and port 80 ports inside your firewall. So if you're in Starbucks or you're on a client site, if you're a consultant, or you're just within your corporate environment, it provides a secure way that you can go ahead and connect. Importantly, when I say you don't need IT to do anything, you don't. It does not allow Azure access to your network, though. So to be clear, it's a one-way kind of connection. So you're not actually opening up a security hole within your environment. Instead, what you're doing is enabling your dev machines or your individual machines access into your Azure environment. And again, it's great for dev test. You can use it also for production as well. So how do we do this? Well, so we go into Azure here in the admin tool. One of the resources we let you create is what's called a virtual network. And so you go to Network Services and create a virtual network. And we let you create one. You can go ahead and specify a subnet range. You can wire up your DNS settings, add local networks, a variety of different options here. And it's a fairly simple wizard to walk through. I've got one that I've already created that we'll look at, called the Scott Guthrie Virtual Net. We got a nice help thing, and then if you click on the dashboard, you can actually see kind of the health of this virtual network. You can see basically, I don't have any clients connected to it right now, but last night when I was doing my testing, I did about 255 kilobits in, and I downloaded about a megabyte through it. And you can see I basically set up an IP address, or I have a virtual machine running that's joined with a private IP address. And if I wanted to turn off this gateway, all I have to do is just hit delete. And I can then go ahead and download this client software through the Quick Glance that I can now give out to any developer on my team that I want to allow to actually connect to this virtual network, and in doing so, actually connect to this virtual machine. Now, this virtual machine right here is called Scott Guthrie VNet Dem 2. I mistyped and forgot the O, in case you're wondering why it's called Dem. And we'll just bring it up right here. And so this is a virtual machine, much like the ones you've seen me use earlier. One thing that's interesting about this virtual machine, though, is if you zoom in on the right-hand side, you'll notice that I don't have a public virtual IP address set up for it. I only have what's called an internal IP address. And the reason for that is because if you click on the Endpoints tab, I've actually turned off all outside ports on this machine. So there's literally no way on the internet that someone can go ahead and connect to this. There's no IP address, there's no ports allowed, there's no way for me as an end user or you in the audience to ever even touch this machine. You can't even ping it because there's no network access. However, I did actually join this machine onto a virtual network. So it's on that Scott Guthrie virtual network, which means that if I tunnel into that virtual network, I can actually access it using its private IP address that's only available to people on that network. And so that's what I'm going to go ahead and do. Again, this would be useful for if you've got a dev test environment with lots of different machines. You can stand them up on your virtual network inside Azure, and then you can have your developers be able to tunnel into them, and then they can talk to those virtual machines just like they would if they were down the hall. And you don't have to worry about anyone outside your organization even being able to sniff that the machine even exists. So it's a very secure way in order to actually do communication with them. And basically, to enable it within Windows, all I need to do is click on this, which shows me my network tab. You'll notice here I have something called Scott Guthrie Virtual Network. I can go ahead and hit connect. Notice our snazzy little graphic there. And basically, this is going to set up a VPN connection. And basically, that was it. And now I'm actually VPN tunneled into Azure, and specifically my Scott Guthrie network, virtual network within Azure. And now this virtual machine, which I can't hit remotely, but I can through a public IP address, but I can using a private IP address. This is just a 10.0.1.4. And I couldn't remote desktop in before because it basically didn't have an IP address. But now, because I'm part of that virtual network and I'm securely VPN'd into it, I can now access this just like this was literally a machine sitting next to my dev machine in my office. And I'm now tunneled in. Everything's secure, everything's encrypted. I could have any number of machines talking to each other over public local IP addresses. And if I want to, I could basically give out this cert so that other devs on my machine can VPN as well, and then they can connect as well. And so it basically lets you set up a completely private virtual network, all your own. Everything is tunneled over SSL. Everything's VPN. Nothing is available to the outside world. And you can see you can connect to that literally in seconds and stand up this environment in no time at all. So there's lots of demos in terms of creating virtual machines. How do we actually put this in practice? And everything I've done through the portal, you can also script and do through the admin tool. The other thing I should just mention is inside Visual Studio, with the latest Azure tool release that we just did recently, if you click on the Server Explorer, you'll notice we now show you all your Azure resources inside Visual Studio. If I click on refresh here for my virtual machines, this is going to reach out to Azure. It's going to find all my virtual machines. There's my Access DB Rocks VM that we created earlier. Directly inside Visual Studio, without even having to log into the Azure admin tool, I can now shut down and restart that virtual machine directly inside VS. And if I want to, I can go ahead and connect to it. And I can literally just remote desktop in directly from my virtual, from Visual Studio, and yes, for all these dialogues, this is the first time I'm doing it. But you can basically see, that Access Rocks server running in North Europe. Now inside my Server Explorer, I can stop it, I can start it, I can restart it, I can right-click and log in. This is the very first time that we've logged into our Access Rocks server in North Europe. So this is going to basically set up Windows the first time and configure IE and a few other things. And in about 5 seconds, we should see 4, 3, 2, 1, 0, 1. We should see the Windows desktop. There we go. Basically launched. This is the first time we've ever activated this machine, so that's why it's doing a little bit of extra setup. But now I can basically install Access within it or anything else I want to. Again, I could join it to a virtual network. I could tunnel to it. And the beauty inside Visual Studio now is when I'm done with that, and I say, hey, you know what? I don't need that Access database after all. We'll just shut it down. And I can go ahead and restart it, or in this case here, by hitting shut down, it's literally just going to power down the virtual machine for me, all within my dev environment. So that's a little bit in terms of kind of some of the stuff you can do. We'll talk a little bit about some of the features we've added here this summer, just from a licensing and pricing perspective, that I think make it this type of infrastructure here really good, not just for production scenarios. Hopefully you saw we have lots of capabilities to add a reliable kind of system. But from a dev test perspective, since most people in the room didn't raise their hands when they said they used Azure, make sure you know about. One is, I showed you right just there how I could stop the virtual machine directly inside Visual Studio. One cool thing that we've recently did a couple months ago is now when you stop your virtual machines, if you don't delete them, we don't charge you for them. So if you delete them, we don't charge you for them either. But in the past, you used to have to delete virtual machines to stop the charge. Now you can actually just power down that Access DB Rocks, and you're not going to pay any compute time for that virtual machine. You will pay storage if you save lots of disks, but it tends to be kind of pennies per gigabyte. But now it basically means you can start and stop virtual machines at will using that nice Server Explorer view. You never even have to log into Azure and know that you're only basically paying for the virtual machines that are running, which is kind of nice. We've also kind of moved to a model this summer, starting in June, where we only pay by minute. So that Access DB, which basically is only run now for about 30 minutes, we're only paying for half of an hour of compute. If you only run this thing for 2 minutes, you're only paying for 2 minutes prorated of compute. And so it ends up being kind of a very cost-effective way that I only pay for what I use. We've added full MSDN use rights. So if you're an MSDN customer, you can now use all of the standard server licenses that you get as part of MSDN inside Azure. We're actually the only cloud provider right now that lets you use MSDN use rights. And so if you want to stand up SharePoint or SQL or BizTalk or Windows Server, you can do it at no extra license cost inside Azure. Cool. I love getting applauses for licensing. Well, I'll take it. The other thing we've done that's pretty compelling is we basically have a special MSDN dev test rate now for running virtual machines inside Azure. And so the standard rate is what you'd pay by hour. Those are pretty comparable. I think it's the same rates you get on Amazon. But what's nice is if you're an MSDN customer, notice that second row, that's basically what you pay now for dev test scenarios. And that's the savings on the right-hand side. So basically, it's 33% cheaper than the other cloud provider out there just for running a vanilla Windows server. And if you're running something like SQL, its base one was 97% cheaper and actually to take advantage of if you're an MSDN customer. So that translates into real savings. Now, what's nice about this is you can run any number of virtual machines at these discounted prices. If you want to spin up 30,000 virtual machines, you can. And run them at this discounted rate. So it's unlimited amounts of storage of capacity that you can do. To make it even sweeter, though, we're giving you free credits so that you can run as many virtual machines as you want with those previous rates. We're also then giving every MSDN customer out there a free set of credits every month that you can spend on those virtual machines or any other Azure resource you want. So if you're a pro customer, you get $50 a month, premium 100, ultimate 150. And again, you can spend them on any Azure resource you want. So a couple things you could do. You could spin up, if you're an MSDN premium customer, 3 virtual machines that you use for 16 hours a day, 31 days of the month. If you use autoscale, you could basically turn them on in the morning, turn them off at night, or you could basically control however you want just using the Server Explorer. And at that rate, at $100, you wouldn't pay a single penny for the entire month. And this you can do every single month. There's no one time only. This basically applies every single month. You could also, if you wanted to, do a load test run. How many people have ever had 80 servers that they've spun up a load test for? Yeah, one person, good. How many people here know that they probably should have done that before they went live? Yeah. Now you can basically spin up 80 virtual machines for a 20-hour load test at no cost. Again, that all will be covered inside that $100 a month credit. You could spin up 50 HD Insight nodes. So if you want a Hadoop cluster of 50 cores, you could basically spin up 50 Hadoop servers and run the job for 10 hours. You could go ahead and run up to 100 websites with a SQL database. Again, basically, you wouldn't have to pay anything as part of this. Make it really easy to figure out how much you paid inside the portal when you sign up with an MSDN account. We have a little thing, medallion at the top you can click. It'll tell you how many credits are remaining when we estimate you'll run out. And if you click details, you can actually see your exact burn down curve and see how much time is remaining on any of those. And what's nice about this is it's all built in. Again, you don't even, when you sign up for Azure, if you're an MSDN customer, you don't have to enter your credit card. So just basically go to our website, use the same Microsoft ID that you've associated with your MSDN account. So if you log in the MSDN website, use the same ID. And then basically within about 30 seconds, you can be live. And every single demo I've done here this morning, you can do as well as part of your MSDN account, including running that virtual private gateway. So you can spend your MSDN credits on those as well. And just to make it a little, even sweeter, if you sign up before September 30th and you build, I think it's either a virtual machine or create one virtual machine or create one website, you basically get entered into an automatic drawing to win an Aston Martin V8 Vantage car, which is about a $250,000 car, I think, or 150,000, something like that. It's an expensive car. And we pay the tax, so don't worry. And literally all you need to do, go to Azure, sign up, create something, and you automatically enroll as part of that. And one lucky winner will drive away in a pretty sweet car. But even if you don't win, hopefully you've seen just by walking through kind of some of the experiences I showed with the infrastructure as a service, as well as some of the dev test offer. If you're an MSDN customer, there's really no reason not to use Azure to basically do your dev test. All the stuff I showed here works whether you're deploying in the public cloud and you want to basically turn your customers loose on it and run those systems in production. But they also work even if you're just actually deploying to your existing on-premises environments. Because it's just running Windows Server, because you can run SQL, you can use .NET, you can use IIS, you can use VS. In the public cloud, you can basically build and deploy those same applications and test them in the cloud, and then deploy them into an on-premises environment. So hopefully, lots of things you can take advantage of there. One of the things that we kind of mantra that we have with Azure is sort of this focus on apps, not infrastructure. And so I basically just touched the surface in terms of what you can do from a capability perspective, and just focused on the infrastructure side so far in this talk. But we have a lot more features in that portal and inside Visual Studio you can take advantage of as you're building your applications. And one of the things that we provide as part of our service is a bunch of prepackaged services that you can leverage, where instead of you having to think about virtual machines, instead of you having to think about patching machines or configuring for backup or things like that, they're kind of built into the environment, and you can basically take advantage of them in a really easy way as a developer, and basically scale and run them even better as well. And so what I thought I'd do, just to wrap things up, since I have 30 seconds left, is just kind of quickly walk through maybe 2 of them to give you a flavor of some of the more than 30 different services that you can leverage as developers, and kind of hopefully whet your appetite to learn more. So first one we're going to do, we created virtual machine earlier. Let's create a website. Any ASP.NET developers in the audience? Cool. I love you. So, no, we won't call it Access. We can call Scott Gu VS Live Web 2 web demo. I can pick, again, where I want to deploy in the world. I'm just going to say East US here. I can pick also what sort of subscription I want to run this on. Use my pay as I go. And so I'm just going to basically create a website. You saw me earlier creating a virtual machine. The virtual machine we're kind of deploying on a server and running, and I then had to tunnel in. If I wanted to, I could install IIS and things like that. The nice thing about our website model here is we do all that for you. So literally in about 6 seconds there, we created this website. I can click on it, and I now have a website that's available that will basically host any ASP.NET application, and I can deploy to directly, that's now available on the internet. And so that was literally how easy it was to create a website inside Azure for hosting. Let's now go into VS. We'll create a new web app. I'm going to call it VS Live Demo 2. We'll make it an MVC app. I'm using VS 2013 here, but I could also go ahead and just use VS 2012 or VS 2010 as well. That all works with Azure as well, and we have great tooling for it. And so now I have simple ASP.NET MVC app. If I want to deploy it to Azure, just right-click and hit Publish. I can go ahead and populate here, and it's what was the name of the site? Scott Guthrie VS Live Web. I created a test one last night, but this is the one we just created, right? Scott Guthrie VS Live Web. It's going to work much better if I get that right. Good. I basically picked, that's the site I want to deploy this to inside Visual Studio. And now all I need to do inside VS, I've created that ASP.NET project. We've created that host up there on the server. I'm going ahead and hit deploying. And what I should see in about 6, 5, 4, there we go. There's my ASP.NET project that we just created, deployed live, deployed on Windows Azure. I didn't have to create virtual machines. I didn't have to set up anything. Literally, as a developer, that was how quick it was for me to go ahead and try this out. And if I want to, I could go ahead and say, notice where it says, where does it say that? If I go ahead here and change my home page, there's a bunch of content here. We could nuke all this and say, access rocks. There we go. Hopefully no one's taking pictures of this. But anyway, I can go ahead and right-click. We support what's called incremental deployment. This is all built in. It uses the same web deploy technology that you can run on your servers on-premise, but we basically are running this automatically for you in the cloud. Notice it's saying, hey, you're only updating 3 files, so now when I deploy it, instead of having to redeploy the entire application, we're basically just redeploying those 3 files. Makes it really fast. And you can basically see we've created an app in the cloud, ASP.NET app in the cloud. We deployed to it from VS. We made a change. We redeployed. Everything's happening in seconds. And this is basically how easy it is to create a website up there that you can go ahead and take advantage of. Cool thing about Azure is we give you, every customer, 10 free websites forever. So you can basically do this literally at no cost. We also give everyone a free SQL database, up to 20 megabytes for free. And so you can do all your development literally at no cost. If you're an MSDN customer, it's even better. And then when I want to, I could go ahead here. I can now see statistics in terms of internet traffic coming to my website, my wonderful Access website. And the other thing I'll just mention in terms from a scale perspective is if I ever want and need more capacity, I can scale up the number of virtual machines this is running on. All I need to do is hit save. And at that point, this site will be scaled out to 3 virtual machines that are small. Cool feature that we also kind of enable is what we call auto scale. And so one of the things I could do is I could say I want to use up to 3 virtual machines. And I want to make sure that my target CPU on the machines is kept between 32 and 63%. That means if my machines ever go above 63%, I'll start adding machines up to 3 of them. If my CPU ever is under 32% for, say, a minute, we'll start turning off machines to save you money. And literally all I need to do is just configure this, hit save, and 5 seconds later, I've got auto scale set up for this website that we just created. So this gives you, I know it's a bit of a whirlwind, but hopefully a sense of, it's not just virtual machines we do a lot more. You can do this with websites. We have a similar model for databases, for Hadoop clusters, for media jobs, for business intelligence, and a bunch more capabilities. And the beauty is you can leverage these kind of services we call platform as a service, where we're doing the management for you. You can combine them with the virtual machines that I showed earlier this talk. And if you're an MSDN customer, you can do that literally all for free. So definitely give it a try. Love to get your feedback on Azure. Send me mail if you have any bad experiences or a good experience. To get started, if you want to try it, go to azure.com or windowsazure.com. Again, anyone can sign up for free. Everyone gets a $200 free trial. If you're an MSDN customer, though, as part of the free trial process, just click on the free trial tab. Click Try It Now. Use the same Microsoft ID that you use with MSDN, and we'll automatically set you up as an MSDN customer. No credit card required as part of sign up. You can do all the demos I did here this morning, and hopefully use it for your dev test environments going forward. So thanks a bunch. Hope you enjoy the conference. Have a great day.